In this video, we're going to see a completely new Mustang RTR that will be transformed piece by piece from a stock version into the drift car of the YouTuber James Deane. He's got only 40 days to achieve a dream he's had for years. But before we start this insane modification journey, don't forget to subscribe here at Twin Power. And let's go broadcast some American drifting. At the very beginning, the car arrived to him as a chassis and two V8 engines. The goal was to make it fully dedicated to competing in the Drift Masters Championship. There was also a second shipment that was about to arrive in a few days, and in it were the custom drift body shell, all the suspension system parts, and new tires. It also included a modified drive shaft. The team started removing the outer body panels so that only the chassis would remain. That way, once the drift body arrives, they can install it immediately. They removed the doors, the hood, and the trunk lid, finished that, and moved the chassis into his workshop. Then they began cutting off many parts of the chassis with the goal of reducing weight as much as possible. Because, of course, any drift car has to be extremely light. Also, so it could fit better with the roll cage that would be installed, which has the job of keeping the chassis strong against bending and protecting the driver in case of accidents or strong impacts. They cut the roof completely and removed all the unnecessary arches and supports inside the chassis. Cup holders and inner door handles, all that has no use in a project like this. They cut the panels in the rear quarter area and removed the entire rear section to be able to install a crash frame and a new fuel tank. They used a chisel to open the welded areas and cutters to remove the tongues and brackets they didn't need. His goal in this weight reduction phase was to make it close to the weight of the BMW Eurofighter, which ranges around 1,370 kilograms. What made it even better was that the Drift Masters tires they were using were perfect in terms of softness and traction, even more than the FD American Championship tires. That allowed the radiator to be mounted at the front and reduced the weight in the rear. Several things arrived for this project. The first was the fuel system, consisting of a lightweight, pressurized radium fuel tank with a capacity of about 22 liters. Of course, that's less than any normal car, but that's because it's made only for racing. What was special about this system was that it allowed the entire pump unit to be removed quickly, so that it could be replaced with spare parts in emergencies. That ensures that if anything happens, he can fix the problem and get back to the race quickly. The second thing was the control electronics from the company ECU Masters. The ECU was an EMU Pro unit, the same one he used in his Mazda RX-7. He planned to use 10 oxygen sensors to make precise, professional tuning for each cylinder individually. And of course, the display screen in front of the driver had to be digital. It allows the driver to see all the operating data across different pages without needing to connect an external device. It also came with a power management unit. That's the system that acts as a box for the fuses and relays, controlling all the car's electronics directly, eliminating the need for traditional fuses. The engine he had, in its naturally aspirated form, was designed to comply with the European competition regulations that he wanted to participate in. It's supposed to rev up to 9,000 RPM and will run on a direct nitrous injection system. After that, they moved it to their friend's workshop to start the welding and fabrication work. they cut the original transmission tunnel and made a new one, larger and straighter than the stock one. That's because the original Mustang tunnel slopes downward at a certain angle, unlike the new tunnel, which provides more space for a racing gearbox installation and also makes room for fitting the hydraulic handbrake lever and the gear shifter. They also cut out space to install a mount for the new fuel tank in its position, and prepared everything to install the main hoop of the roll cage. He made sure that when it's fitted, it doesn't touch the roof at the highest point possible. In this shot, he's adjusting the seat position and fixing it in its proper place so he can be comfortable and have the longest possible line of sight ahead of him in the car. They fixed the front engine mounting plate and welded it in place. This step will make it easier in the future to remove the entire engine assembly. All the outer panels he was going to install were made of Kevlar instead of regular carbon fiber. That was to make them stronger and more resistant to impacts during races. He began fabricating and installing the protective wall behind the driver's seat to separate the driver from the fuel tank. The transmission tunnel was fully welded and secured, a large tunnel providing excellent space for the gearbox, the starter motor, and the roll cage, which was almost completely installed and fitted very tightly against the roof. That gave the driver the maximum possible space to get in and out of the car. After that, they welded the pedal box in its final position. They finished welding the upper section of the strut towers strongly to the chassis. This was to increase the structural rigidity so it could handle the wide suspension system and hard impacts. They brought the Ford RY45 engine to mount it with the Samsonas RS9 gearbox. To weld the engine and gearbox mounts accurately, James and the rest of the team took precise measurements of the engine position from an American car. That's why they decided to place the engine in exactly the same spot in the Mustang, to make sure everything fits and works perfectly. They made a new mount and welded it under the gearbox. At this point, they finished welding all the door bars and began mounting the gear shifter and the handbrake lever. They still had about 35 days left to finish everything on the car. He installed an aluminum panel to act as a shield. It surrounded the fuel filler hoses that came from the quick fill port on the side panel going toward the fuel tank. The importance of this panel is that it keeps any fuel leak or vapors completely outside the car's cabin, which increases safety and protects against fires, especially since race drivers spend long hours inside the car. They finished welding and securing the entire roll cage, including the side door bars that provide extra protection and rigidity to the chassis. They also fixed all the engine and gearbox mounts and connected the drive shaft to the differential. And they found that all the measurements were accurate to the millimeter, which was a huge win for them. They installed and secured the brackets that would hold the oil lines and pipes for the dry sump system, so everything would be neat and organized. After exactly 10 days from receiving the car, all the fabrication work was practically done. They started preparing it to enter the paint booth, so they moved the chassis from their friend Harris's workshop to the paint shop SMP Auto. There they prepared the entire chassis before painting it with a material called sealing joints. It's like a sealant that prevents leaks gives a clean final look and stops water from entering the gaps. They used a device like a rotating stand that holds the whole car so they can spin it, making it easy to reach all the lower and hard-to-access areas, for example, the parts underneath the chassis, and make sure the paint reaches everywhere. Before doing anything else, they first sanded every part of the chassis to make sure the final paint would stick properly. The first layer was a primer coat, which covers imperfections and makes the surface completely smooth. After that, they sprayed the main color, the same gray used on RTR Mustangs in America, called Vaughn Gray. Then came the polishing step, 2 or more layers of clear coat to give the final shine and smoothness. The entire painting process, from primer to color to clear coat, was completed in just one day, saving them a lot of time and effort for other work. They finished and returned the chassis to the main headquarters of HGK Racing to start assembling it again. The car was completely clean, straight, and freshly painted, ready for the new stage. They started installing the car's suspension system. They used BC Racing suspension, the same type he used in all his previous cars. After that, they began connecting all the oil lines and fuel hoses from the engine to the rear of the car. Then came the turn for the control electronics from ECU Masters. They installed the EMU Pro unit and the PMU Power Management unit, and began connecting all the electrical wiring neatly and precisely. The important thing is that all the wires be separated and organized into sections. For example, sensors, ignition, fuel system, engine control, so that in the future, if anything goes wrong, it's easy to identify and fix. They also installed the main fuse switch and the fire extinguisher system. This system sprays a special liquid in case of a fire inside the car or the engine bay. Then they installed the electronic power steering pump and connected it to the main oil lines. They used a lightweight racing radiator for cooling. It's much smaller and lighter than a standard car radiator, but gives strong performance and high efficiency for race use. After that, they fixed the quick-fill fuel system. It allows the team to refuel the car in just a few seconds during the race. They installed the new engine in the chassis, and this was a special and emotional moment for them because this step made the car finally start to take shape. After that, they installed the gearbox and all the connections between the engine, gearbox, and differential. Everything fit together perfectly, and that confirmed that all their previous measurements and welding work were spot on. They installed the dashboard, which had a digital display showing all the data, like RPM, temperature, oil pressure, fuel pressure, and nitrous status. They mounted the pedals, the handbrake lever, and the shifter in their final positions. Then they started connecting all the oil and fuel lines again and filled the systems for the first time. They also installed the dry sump oil tank, which keeps the oil pressure stable even in extreme conditions, like when drifting at high G-forces. He also installed the exhaust headers, custom-built stainless steel pipes designed specifically for this engine and chassis. Each cylinder has its own pipe, and they all meet at one collector, producing a strong and unique sound that's characteristic of race engines. After that, they installed the drive shaft and connected it to the rear differential. Every step was done carefully and precisely, because a small mistake could cost them a lot later on. They fixed the oil cooler in the front bumper and connected all the lines running from the engine to the cooler, making sure all the clamps and fittings were tight. They began connecting all the sensors that monitor the car's operation, like the intake temperature sensor, coolant sensor, and crank position sensor. Finally, they began installing the car's exterior Kevlar panels one by one: the doors, the fenders, the hood, and the bumpers, until the car started looking complete again. At this point, they finished about 90% of the car's assembly. What was left were the final adjustments, and, of course, the first engine start. At that moment, the long-awaited day finally came. The day to start the engine for the very first time. Everyone was nervous and excited at the same time. They had spent months of work, sleepless nights, and countless hours on this project. And now it was time to see if everything would actually work. They filled the oil, checked the fuel system for leaks, and verified all the electronic connections one last time. They turned on the ignition. The fuel pump started buzzing, building pressure. Then, James pressed the start button, and within seconds, boom! The Ford RY45 engine came to life for the first time. A deep, aggressive roar filled the workshop. The sound was pure, raw, and incredibly loud. The kind of sound that instantly tells you this machine was built purely for racing. Everyone smiled, cheered, and clapped, because that moment meant everything they had done was worth it. The engine idled smoothly, and the ECU readings showed that all the sensors were functioning perfectly. Oil pressure, temperature, air-fuel ratio, everything looked perfect. They let the engine run for a while to reach its normal temperature, then tested how it responded to throttle input. The revs climbed sharply, and the car's whole body shook with power. That was the confirmation that the entire setup, from engine mounts to electronics, was solid and ready. After that, they began preparing it for the first test outside the workshop. They installed the wheels, tightened every single bolt, and double-checked the suspension alignment. James sat in the driver's seat, fastened the harness, and slowly rolled the Mustang out into the daylight for the very first time. The car looked absolutely stunning. Low, wide, with a menacing stance and the signature gray color shining under the sun. He gave it a few gentle revs, and the sound echoed across the entire area. Then came the first real test. He pressed the throttle and let the rear tires spin. The Mustang instantly started sliding sideways, smooth, controlled, and incredibly powerful. Thick clouds of smoke filled the air as the engine screamed to the red line. Everyone around was cheering. Months of work had finally turned into a real, living drift machine. It was a dream come true. A Mustang built from scratch, customized in every single detail, and now officially roaring like a beast on the track. After the first successful test, they took the car back inside to do a complete inspection. They checked every bolt, every line, and every wire to make sure nothing had loosened or leaked during the test. Everything looked perfect. James said that hearing the engine